Why does time move slower in space? What if I told you that an astronaut in space actually ages slower than you? If two identical clocks were started at the same moment, one on Earth and one in space, they would no longer show the same time. And this is not science fiction. This is real physics. But how is that possible? Isn't time supposed to be the same everywhere? How can time slow down or even speed up? And most importantly, how do we know this is real? In this video, you'll discover why time moves slower in space, how speed and gravity affect time itself, and why your phone's GPS would stop working without this effect. Let's begin. In 1905, Albert Einstein changed our understanding of time forever. According to his theory of special relativity, time is not fixed. It depends on how fast you are moving. The faster you move through space, the slower you move through time. At everyday speeds, this effect is so small that we don't notice it. But when you start moving extremely fast, close to the speed of light, time slows down significantly. Astronauts aboard the International Space Station travel at about 28,000 kilometers per hour. Because of this incredible speed, time on the space station moves slightly slower than it does on Earth. So the first reason time moves slower in space is speed. High speed causes time dilation. But speed is only half of the story. In 1915, Einstein introduced another revolutionary idea: gravity also affects time. The stronger the gravity, the slower time moves. Near massive objects, time passes more slowly than it does farther away. On Earth, gravity is relatively strong. In space, gravity is weaker. That means time in space actually moves faster, unless speed slows it down. Near a black hole, gravity becomes so intense that time almost comes to a stop. 1 hour near a black hole could equal years passing on Earth. This isn't just theory. GPS satellites orbit Earth high above its surface. Because they experience weaker gravity, their clocks run faster. Engineers must constantly correct these clocks. Without Einstein's equations, GPS would be inaccurate by kilometers every day. In other words, your phone's navigation works because Einstein was right. NASA astronaut Scott Kelly spent nearly 1 year in space. When he returned to Earth, he was slightly younger than his identical twin brother. The difference was tiny, but it was real and measurable. So let's summarize. Speed slows down time. Gravity slows down time. And space involves both. Time is not the same everywhere in the universe. Time is not a simple ticking clock. It bends, it stretches, and it depends on where you are and how fast you move. If you enjoyed this video, don't forget to subscribe, because the universe has many more secrets waiting to be explored.